Hello world, this is Aditya and we are going to start some later topics just like pointers. Pointers and references are highly complex and difficult to master, but they can greatly improve the efficiency of the programs. For novices, avoid using pointers to your program. Improper using can lead to a serial logical bugs. However, you need to understand the syntaxes and passes by reference with pointers and references because they are used in many libraries function. So there are four types of passes: pass by value, pass by reference with reference arguments, and in pass by reference with pointer arguments. So first of all we have to see pass by value. Pass by value is a clone is made and passes into the function. The caller's copy cannot be modified. And the second passes by reference. A pointer is passed into the function. The caller's copy could be modified inside the function. The third one passes by reference with reference arguments. Use the variable name as an argument. And the fourth one, the last one, passes by reference with a pointer arguments. You need to use address variable name as an address. Now we will see some dynamic memory allocation and new and delete operators. You probably hear about it. New and delete operators. Instead of defining an int variable, int number, and assigning the address of the variable to the int pointer, just like int asterisk pointer name equals to and address of number. The storage can be dynamically allocated at runtime by a new operator in C++. Whether you allocate a piece of memory dynamically, why new? You need to use delete to remove the storage, just like to return the storage on the heap. The new operator returns a pointer to memory allocated. The delete operator takes a pointer pointing to memory allocated by new as a sole program. For example, let's check a program that new and delete operator work as a pointer to initialize and allocate memory. You can use to initialize for fundamental types or invoke a constructor for an object. For example, let's check a program. You can dynamically allocate storage for global pointers inside a function. Dynamically allocated storage inside a function remains even after the function exists. For example, this one. The main difference between a static allocation and dynamic allocation are: in static allocation, the compiler allocate and deallocate the storage automatically and the handle memory management, whereas in dynamically allocated, you can use the programmer handles the memory allocation and the deallocation yourself. By new and delete operator, you can full control and pointer address on their constraints as well as their memory management. Now second, a static allocates entity and manipulate through named variable. Dynamic allocation entities are handled through the pointers. Got it? So new and delete operators. Let's check out some more information about new and delete operator. Dynamic array is allocated at runtime rather than compile time by the new operator. To remove the storage, you need to use the delete operator instead of simply delete. Okay, you have to use the delete array sign. For example, just like this. 0.03 version does not allow you to initialize a dynamically allocated array, and C++ 11 version does with the base initialize as follows, just like int asterisk p is equal to new int array. That's it. Now we will get some more information about pointer, array and function. Array is treated as pointer. Why? How? How much? Why not? Okay. In C, C++, an array name is a pointer pointing to the first element, index 0 of the array. For example, suppose that a number is an int array, number is also an int pointer pointing at the first element of the array. This is number is the same as address of number 0. Consequently, asterisk number is number the first block of array. Asterisk number plus 1 is number as array 1. For example, let's check in this program. It will give a better understanding. Pointer arithmetic. Did you have ever listened about it? No. Then listen here. So pointer arithmetic, as seen from the previous section, if number is an int array, it treated as the int pointer pointing to the first element of the array. So number plus 1 point to the number int instead of having the second sequence address. Take note that int typically has 4 bytes, that is a number plus 1. Increase the address by 4 or size of int. For example, this size of array, the operation size of array returns the total bytes of the array. You can try the length, the size of the array by dividing it with the size of element, example element 0. For example, this one, passing array in or out of an function. An array is passed into the function as a pointer to the first element of the array. You can use array notation, example int array, or pointed notation, example int asterisk. These both are same. The function declaration, the compiler always treated as the pointer, example int asterisk. For example, the following declaration are equivalent. They will be treated as int asterisk by the compiler as follows. The size of the array is given in the array block is ignored.